Okay, thank a lot to the organization so to invite me to make it possible online. So it's a hard time for this pandemic, so it will be an awesome experience. It's my first time online. Let's do it happens, right? And I wanted to share right now is all my experiences since I become like a data engineer and all the mistakes and the success that I achieved after doing a lot of mistakes, of course. Um, let's present myself. I'm a developer with more than 16 years of experience. I'm originally from Brazil. Actually, I'm living in Berlin, Germany. Uh, I've been learning Python since I started to learning programming. Python followed all my career. So, of course, I transitioned for different technologies along this time, but mainly using Python as much as I can for several reasons. But Python community is a passion as well. I'm deeply involved with software communities, especially in Brazil, and I helped to organize several conferences. I know how much work you need to do for organize a conference. So thank you again the organization for making it happen. I would like to hear from you feedbacks about my talk in my Telegram. That's BSAO0, or my Twitter, BSAO. And I'm currently working at Microsoft as a data engineer for a product named the Microsoft To Do. That's a task list. Is a pretty awesome product. So try to enjoy the product. Uh, this is a small agenda that you talk today. It's not about the code. It's not about programming. It's about how Python fits in the data engineer roles and some learning the lessons about the data products, right? We'll talk about anatomy of a data product. It's just to equalize our knowledge about this aspect of a software compute program. You talk about two kinds of architecture, two kinds of model architecture. It's one Lambda and one Kappa. You briefly talk about the quality of a data pipeline that basically is the quality of a software computer. Computer software, and then where the Python matters, that's most important for us. When you can use Python and each aspect of a data product. My goal for this presentation is to starting helping you to playing a great data-driven product, right? Let's talk about the anatomy of a data product. This is very interesting because in the big data world, so you have one thing that's named the 5Vs that describe the aspects of the big data, right? And each V of these aspects, it fits in one part of one data product. Everything started to happen in ingress part, or how you call it, when you collect all the data that you need for a product. Today, it can be like a telemetry, logs, database, interaction, events, whatever you can collect from interaction of one software with the other or one user with one software can be considered a data, right? And in this collection, this ingress happens in a layer or in a part named the ingress, of course. And there's two V's that fits these parts: the volume or amount of data that you collect from these another parts, and variant of this data. It can be like hot text, it can be images, audios, interaction, whatever you want. And which kind of data you hold in this part. So is a structured data, is a unstructured data. So you need to define it, right? And all this kind of data is stored in one thing named data lake. Data lake basically is a big place where you put everything related with the data. binary data, hot text data, images that I told. So everything is centered on the ingress or data lake, right? Together, you have another part that's the process. The process when the magic happens, when you get this raw data and transform this data in data that can be start to be consumed. Or it means when you start to bring the value of your data, right? You are talk, let me put here. We're talking about this part, okay? When you need to process this data, or you get all this variant of this data and start to process. And when you try to bring the truthfulness of this data. For example, so you can ask for yourself or ask for your team. So our manager, our team can rely on the data that you are processing. So you started to process in this part. So, and this is the code. This is the data sets. Data sets basically is part of this data that you start to process, okay? And together with the veracity, you have the velocity. How many times do you need to process this data? How fast you can process this data? This matters, right? Imagine a bank that you needed to process the payments, credit cards that you needed to prevent the frauds, social networks, ad platforms that you needed to bring for you in milliseconds or to decide in milliseconds which kind of advertisement they needed to show to you, right? This happens in this layer named the process, right? And the egress when you serve this data, right? So you put this processed data in database, or you serve this data in APIs that it can be consumed for different softwares, or you can plot in a dashboard. This is very important. This veracity is a thing that's common related with value. Value is very important. So it's how you see the insights of your data, how you can discover the things, the issues based in the data that you process, how can you rely in your data. It is very important. Based on these premises, you have the anatomy of the data product. This is different for the architecture. This is the anatomy, like a body. So you have your arms, you have your legs, so you know how your body should work, which part of your body should work, but exactly how we implement it, it's not exactly sometimes how it works. It's important to have this differentiator. If you look at this plot, basically the same. So this is a computer programming, right? So you have the input. Input is like you're clicking your button in a software, or you interacting with your app, or a command line application doing some batch process for you. So you have these inputs, and inside your computer you have like functions, variables. So it's interacting in memory RAM, and you have the process. In the end, you have the output. The output can be in a window, a table, or another API that can be consumed. If you see a data product, basically is a computer programming, nothing different like that. Talking about how you implement this anatomy. So today you have like mainstream architectures that well used for the market. One is a Lambda architecture, and another is the Capta architecture, right? I will describe briefly these architectures in order to you have to equalize this knowledge, okay? The first one is Lambda. Lambda comes 10 years ago, more or less, as to bring to us, how can I say, to bring it to the market a layer above of the just a simple map reduce model, right? And they brings the idea to deal with a huge amount of data in an efficient way. And here you have two premises. One is to reduce the latency between the process, right? So you can get a huge amount of data and process it in a small window time frame, and try to be near real time. This is the first premises. And the second premise is that we call it event source, or any change in the data state should start a new event in the system that can be reprocessed. Or it means every time that you receive a new data, every time you receive a new event, you need to reprocess this data. The concept of the event sourcing basically is make predictions and start the changes in a real-time basis, right? In a historical time. So you receive an event right now, and a few seconds after you receive the new event, you need to store this event in a historical way that you can build a sequence of events. For example, again, a bank transaction. You try to pass your credit card in a supermarket, for example, and you are denied for that. And after, because you faced some fraud detection, and then you try to pass it again, and for some reason it comes successful. You need to understand this behavior along the time because, for example, your machine learning model is failing for some reason, right? So they are identified, sometimes it's a fraud, sometimes not. And this kind of change in the data or the change of the behavior generates a new event, right? Then change the state of the data because first time you got a denied transaction, and after you got a successful transaction. It's very important to understand this concept of the Lambda architecture. This happens inside the batch layer. Batch layer basically consumes the data from the system simultaneously with the speed layer that I explained after, right? And any data that comes from the data lake or for the ingress part that you are talking about, generate a new state of the data, and then you need to reprocess it every time, right? How you receive this data is up to you to decide the time frame, okay? The second part is running together with the batch layer. You are talking about the speed layer. Speed layer is the result of the batch layer. It means every new state of the data, the speed layer get these results and started to proceed and to deliver this data as a new delta. New delta new means a new state of this part of the data in a certain time in a certain time, right? For example, you got a piece of data right now, you reprocessed your batch layer, your data got a new state, and now your speed layer are able to train your machine learning model or to generate a sub data set or a data set of your data and delivery to be carried, right? This is why the speed layer works. They try to work in a near real-time basis to serve the users to reduce the latency and the queries to answer the business answer quickly. Okay. Just important to mention that batch layer, it's one thing. It's not about the real time, okay, but speed layer is is near real time, okay. In the last part, you have the server layer. And the server layer means that where the user or the system come to get served about the data that you process. Here you have two ways. One way is the batch layer that permits you to query your source of truth. It means the data lake and all the batch views that you have. For example, for each state of the data that you have in a certain time, you can go there and carry that date, or the speed layer that you can consume your data near real-time views with the enriched data. It means at each time that the batch layer produce a new delta, each time that a delta batch layer produce a new version of your data, a new state of your data. They enrich the data in a speed layer. For example, let's get like a social network, for example, that's based in advertisement, like, and then you are interacting with a content based in stock markets, for example, and then you start to collect in these events because you are interactive with stock markets, and for some reason you change drastically your interaction for cats, for example, and then speed layer are able to enrich this data or the link between these two interactions, you as a user to serve to another user to do analytics, for example. What's the relation of a user that has using stock marketing and then change directly to see funny cats videos, for example? This is a stupid example, but just to you understand how the interaction between the layer works, because you need to enrich the data. And then speed layer, you serve the serving layer in order to you enrich the data and get this data in a real-time basis for you. Okay. Let's talk about the application of the Lambda architecture. The first thing is, if your system, if your platform, data product that you are developing, when you are talking about the data product here, is not just pipelines, that's part of the data product, but imagine that you have like a system, like a social network or a bank transaction that you need to store your data permanently, for example. This is one thing that you need to take on account in order to design your architecture. So Lambda architecture fits it, right? When you need to carry your data, and your data should be immutable. This is another application of the Lambda architecture. When the system and users needed to deal with a huge amount of data, and you update this data and serve as a new data set. This is how the Lambda architecture works. For example, you have a huge amount of data about the behavior of your users, and then you need to extract a subset of these behaviors in order to create another data set to serve for different products. It's how the Lambda architecture works for you. And of course, you have like pros and cons for these architectures. The pros is basically is because it's reliable and safe. Why? Because all your data is stored in a distributed file system, right? So if any catastrophe happens, or if you need to reprocess all the data, you can do it from scratch, right? So you can go to your data lake and reprocess all the data, and then you take probably will take a long time, but you can do it. So it's safe for you keep all this data. It's scalable because you can scalable horizontally or vertically. Depends which software you are using, which technique you are using. So it permits you to have this flexibility, especially if you, for example, you are a small company that you are using a cloud-based solution, or you are a huge company that decided to deploy your stack in an on-premise way, for example. Sorry. And if you need to manage all this data, so since you are dealing with a distributed file system, probably like Hadoop or S3 or another storage from Azure, for example, you are able to deal with this fault tolerance issue most part of the time. But you have the cons about this architecture. One of the biggest cons is you have a way to do a premature data modeling, because basically you need to understand how your data started to be stored in your data lake from start in order to avoid a lot of change, because change is hard to get managed in the Lambda architecture. For example, If you decided to change the schema of your own data set, probably you needed to change the code that generated these intermediate data sets, and probably it will bring more problem, more complex to your code. And then sometimes you started to premature data modeling your data, and this become a mess. You needed to take care about that, right? It might be expensive because your data is growing, growing, growing. And if you need to process it in each cycle of the batch process, it's becoming more expensive because you need more machine, you need more compute process, and then you need more storage, and it's becoming more expensive. So you need to plan step by step how your data architecture is growing. And then you talk after about the capital architecture, because you can basically split your architecture in two architectures, right? And as I told, the code can become complex because the separation of the concern of between the layer of the process can be a mess. And then you need to have like a well-tested, you need to invest more time in test your data pipeline with different approaches, regression tests, unit tests, end-to-end tests. So this kind of approach can be expensive for you as well. Now let's talk about the Kappa architecture. Kappa architecture is not a replacement for the Lambda architecture, but an alternative to provide a performance for some scenarios, as I explained before. Sometimes you don't need to store all this data, but just the processed data to server, right? So this is useful for you, and basically Kappa architecture fits basically stream softwares, right? So like software that you need to perform a real time process for analyticals, for user behavioral. Let's see A/B test, for example. You don't need exactly to store all the interaction of the users, but you need to check a small change in your interface, for example, how these are being affecting the performance of your product. The Kappa architecture help you to reach this scenario. For example, Apache Kafka, that's a mainstream or de facto tool for streaming nowadays. You can, for example, store all your events there, analyze this event in a real time, and just serve or just query the result of this analytical in a single stack for you. And it solves the problem to extract the insights and values for your data. But you don't need to store this interaction, for example. You can consider a Kappa architecture as like a simplified version of speed layer. But the Kappa here is more about serving real-time views for one specific problem than storage or deal with stored data. So you need to manage this slightly difference when you decide which approach you want to implement in your application, right? One of my mistakes here. So unless you are desperate for real-time answers, just keep in the batch process. If you are not a bank, if you are not a huge company that will need like a real-time process, because it's very expensive for you to develop it, to maintain, to deploy, stay in the batch process, because near real-time process probably you solve your problem. I commit this a lot of times trying to bring you real-time insights for my clients, my stakeholders, but they learned that 2-3 hours is enough for these guys understand the business. But from the market perspective, you're talking about technology perspective, right? Applications here, as I told. So if you need a well-defined event order, you don't need a well-defined event order, or if you need to interact with a certain time data set, or any time your data set, Kappa architecture is for you, right? System that requires a real-time learning as I told you, social networks that needed to learn with you how you are interaction, fraud detection, ad platforms. So Kappa applications is for that, right? Machine learning models that needed to be reprocessed every time to understand the user behavior doing another user behaviors, right? And the most important things, if your application just the challenge of your application is how you maintain your code, Kappa applications for you. Because even you needed to deal with a huge amount of data coming to be processed in your application, what matters is code. If your code change, you just need to deploy your code again and don't need to reprocess it. You just change the behavior of your code. If you change the behavior of code, you change the behavior of your insights. Like, it's what's matter for the CAP application. Okay, if you need to leverage your machine learning for a real-time basis, it's a pros for CAP architecture, right? It's a good things about the CAP architecture that they let you use to run this horizontally scalable. For example, for the Kafka, probably you don't need to put more nodes, but you need to increase the size of your the temporary storage in your machine, so you can just horizontally scalable this machine. You don't need to put more nodes because the process and the storage will be different for that. So you reduce the amount of money that you are expending in this time. And if you need to reprocess your data, you just need to reprocess this data if your code changes, right? Not if your data changes. If your code changes, you can reprocess it if you want. Different from the approach of the batch layer. Like machine learning model, for example, that change something, you just need to deploy this machine learning model and just keep this data coming, and the final result will be different, right? You don't need to reprocess it. Okay, the cons of this approach. If you introduce a new bug, if you introduce a new error, you need to have a better exception manager for your code. For example, so if you introduce a bug and you need to mitigate this bug fast enough, probably you pipeline will be stopped for a few minutes, or you start to deliver wrong data for a few minutes. Imagine a bank, for example, that deployed a new fraud detection, machine learning, whatever, right? And then you found a bug on that. Imagine how many million of dollars or cash these guys are losing along this time because a small bug permitting some transaction that could not be allowed, for example. So this brings to us the same comes from Lambda architecture. This is the complex of the code, how tested your code should be submitted, right? Now, let's talk about the quality of a pipeline. Independent of the architecture that you decide or the architecture that fits in your solution, imagine it, as I told you, it's a computer program. The problems basically are almost the same. If they're almost the same, basically the industry, the community addressed all the solutions for that with tools, techniques, people, documentation. So the difference that computer programming and a pipeline, for example, basically is the kind of input that you have, right? And there's a quote here that I learned in some lectures sometimes is, if you see that something you get wrong in a software, probably you get wrong in a data pipeline as well, right? The most important thing for a data pipeline here as a data product, right, is the security, because you need to take in account the access level between the data. Who can access your data lake? Who can access your processes data subsets? Who can access the results of your process? It's very important that you keep your level of access in a professional way. especially if you are dealing with sensitive data like transactions, user behaviors, user data. Who can access this data? Imagine that you have a lot of leaks along the time in the industry. Which kind of procedures you need to implement in your architecture to avoid these leaks, right? You need to work together with different teams, operation teams, security teams, how you are introducing your code, right? One of these techniques is using a common format to store your data if you can. For example, Parquet files, Avro files, JSON files, how you can interact with this common format that you can implement this access layer to this common format. Separation of concerns in your code, for example, is a security concern as well. Which part of your code can access which part of your data? How this code can process this data? This is permitted or not? And another thing is avoid hard coding and duplication. It's a mistake as well. Try to dynamize it. If you put hard coding things in your data like formulas, paths, or formula paths, duplication of code, probably you are introducing security issues in your code that can leverage for a leaks or a way that you can permit unauthorized people access your data, right? Versioning about the automation. Addresses is a common thing in the market. So you use your code, so you version your code, you have brands, feature brands, you version your code in a Git and another version system. About the automation, use the power of different tech platforms. Don't try to use just a simple platform for that. Try to mix the tools. Sometimes it helps you, like continuous integrations, a continuous deployment for that, which kind of tools you use. And of course, the code review lint. If everybody knows how to lint a code, for example, let's imagine that you use like JSON schemas for defining schemas of your data sets. It's an example. So you can link this part of code, this part of text or code review in pair programming. Try to automate all the part of the data pipeline. Don't touch your production environment as well. Right? Don't run tests on your production environment because you have access layer. So use all the things that you can to automate your stuff in a data pipeline as you do in a software engineer, right? Monitoring. Let the cloud helping you to monitoring the things. If you are not a big company, delegates the log metrics, the monitoring, the infrastructure monitoring to the cloud for you. It's basically a must nowadays. If you needed to check the logs of your application, that's not the part of the logs that you needed to process. Delegate it to some cloud-based tool, so you have a variety of this tool. Avoid vendor lock-in. Even if you are a big company, try to avoid vendor lock-in. 90% of the tools nowadays is as open source, so you are able to deploy these tools on your infrastructure. You have a vast amount of documentation. You have a huge amount of people in the communities of the big data and data that can help you to develop. So there's no reason to have like a vendor lock-in for some distributions, right? Even if you are talking about the cloud, avoid this kind of vendor lock-in. For example, Azure has like AD Inside, Amazon has AMER. They are like the full distribution of some these big data tools that you can easily remove your code or remove your pipeline from these tools and implement in another tools. This is very important, right? You have this kind of requirements in your architecture. This is most important, how you implement the tests of your pipeline and traceable your pipeline. As I told to you, try to implement in a cloud-based logs, infrastructure monitoring, but if you are deal with a complex pipeline, implement regression tests to see how your data are changed along with the time, and then you can identify bugs on that. especially for models, machine learning models, how you are adapting your code. Try to have like inputs that are deterministic, like any unit tests in software. You have input, you have output. You need to test how it works inside this function, right? Try to focus on the unit tests for your pipeline. Try to fragment your code in a way that you can test small parts of your inputs in outputs. Like if you have just one function that interacts one piece of part of a user behavior, tests well that part and then implement in your code. In the second part, tests all the third-party components of your pipeline. For example, let's suppose that you have a Kafka, Hadoop, and a Zookeeper, Pandas, all these integrated in a tool. Test these third-party tools if this part is available, a disaster recovery for these third-party tools. Everything should be tested. And in the end, so is the most cost, is most expensive for small teams or small companies, implement end-to-end tests for this whole pipeline. It's very important. If you introduce a new component, if you introduce a new feature for that, you need to test all the components, third-party tools, all the regression tests, and you need to see the results in the end as you need. But you need to keep in mind, I need to be trust. So it can be a mistake or can be a successful decision. Test a data pipeline is really cost. It's really cost. You need to know the certain time to implement the tests or which kind of tests you need to implement your data in your data pipeline. If you try to implement all the tests from scratch, probably you lose a lot of money. But if you don't test in the beginning, probably you lose a lot of money as well. You need to find the average on this. Okay. Now let's talk about where the Python matters here. Here I will expose most part of the tools that I worked in the Python world for integrate the tools that I mentioned before, Hadoop, Kafka, Storm, Spark, whatever. But now you just talk about Python, right? I will describe briefly which kind of tools that I worked, and then you can decide more or less. I will give some advices on that. As I told you, I don't show any code, but I will just give you some advice. The first important thing is that ETL. ETL is basically extract, load, and transform. It's where the magic happens in the data world. When you get the hot data, when transform the data, and you when deliver the value. The most important here is the PySpark. PySpark basically is de facto tools for batch process nowadays. PySpark basically is a Python API for Apache Spark. That is a software that was built above the JVM, runs in servers, nodes, right? They have like executors and they have like a master. And then you have like a Python API that you can interact with that, okay? In another hand, you have like a Python tool, is a Python wrote in Python named Dask. Is a parallel compute library as Apache Spark, but is more focused on the analytical computing. Why? Because they integrate, in a nutshell, Pandas and NumPy. Basically, you have just a unique Python stack that you can run in parallel most part of your functions using Python. You don't need a different stack as you need Python Spark. Another tool is Luigi. Luigi is a model in Python that you can build complex pipelines for the batch process. This is important, right? This is a open source project that was created inside Spotify, right? And they have different supports for different kind of data sources like databases, Hadoop, text files. But basically, you can implement a pipeline in a Pythonic way. You can describe your classes. Your classes can interact with other classes, and then you have like complex pipeline that you can manage. It's a very interesting tool. I really recommend you to start your pipelines using Luigi if you can, right? MER job is an old tool that I started to use a long time ago. Basically, you can write your MapReduce jobs in Hadoop. Basically, the concept of MapReduce in Hadoop and run, and they translate the Python code into Hadoop code or Java code, and then you can run MapReduce job in Hadoop, right? I never used the Ray, but they are a parallel distributed Python-like Dask, but they are focused on machine learning ecosystem. I cannot recommend or not because I never use. Reading the documentation seems to be a very interesting product. For the streaming, if you decide for some reason to use the approach of the Kappa architecture, so you can use Faust for using a streaming process, basically for the Kappa processing, Kappa stream for Python, so you can interact using getting the messages or the messages from the Kafka and using as a Python object inside your code or stream process, stream parsing that use the same concept for Apache Storm. I use the buff. I like it to use false, so it's a very Pythonic way to deal with the Kafka streams. I well recommended for that, and you can interact with your Luigi code, for example, if you need. Because Luigi code, you can implement your logic inside in certain methods, so you can use this to implement even Luigi is built for batch process. You can use some aspects of stream processing in Luigi as well. For analysis, so basically you are talking about the Pandas. Pandas is the de facto tool for analysis in Python. Probably everybody uses this one, right? Blazing is an interface that you can consume big data in different ways and interact with Pandas, right? You have OpenMine for BI. I used it once, not in deep, so I don't have like a recommendation for that. But I never used the Origin or neither Optimus. I just introduce it here as an option for you. Okay, this is very important. So if you needed to run a pipeline, even you have a good pipeline, a solid pipeline, you need to manage and you need to schedule it like a cron job. But Python has Airflow. Airflow was built by Airbnb a long time ago. Now it's an open source project of Apache Foundation. And there is a complete platform for you programmatically schedule and monitor all your workflows. You can integrate with Luigi if you want, or you can create our own batches and streaming process using Airflow. Airflow can replace Luigi if you want, or you can work together with Luigi if you decide. Nowadays, in my personal experience, at least in the last 2 years at Microsoft, I'm using Airflow to manage and schedule all my pipelines. It's easy to deploy, it's easy to Dockerize, for example, it's easy to ship. My monitoring and my scheduling, my monitoring and scheduling, my management as well. So if I needed to change any part of my code, if I needed to change any part of my pipeline, I can just redeploy it and run a backfill. I can reprocess everything using just the Airflow with a few clicks. I don't need to execute anything by the command line or whatever. It's a really good tool for that, right? For the tests. So, of course, you have a PyTest for test your code, but it's very important that you need to simulate tests, data tests. So, like create a fake amount of tests, or you need to create Spark data frames. I didn't tell before, but Spark uses like a different data structure inside it though, so you need to mock these data frames. It's different from data frames from front, but you need to mock this data frame from most part of the time. So you have this framework that is in the GitHub, Spark testing base, so that you can mock the behavior of Spark to you test your code. It's essential for PySpark code. Fake2DB, if you need to test the database generated to test your code, right? And for the validation. Validation is very important because when you define your data scheme that is being ingressed for your data lake, for example, or the data scheme that you are serving for a certain amount of APIs, you can use some Python tools for that. Serverless is one of that. I guess you have like a talk about that today. And you have a schema that you can validate your Python data structures, or Volupy tools. That's another Python tools. So you can integrate with your pipeline, and then you can fix, as I told you before, about the premature data modeling. So this kind of tools can help you to facilitate this kind of modeling and fix some schemas that you need to start to ingress your data. So this is good, right? I finished my talk. Hope to bring some insights for you. Hope to bring some experience that I have. Sorry if my accent or my English is a little bit bad. So I will try to improve. Of course, it's part of my accent. It's possible for you. Now you open a channel for questions. If you have any questions, please. Reach me by email if you want, hello@bison.me, or please ping me on Telegram or Twitter. I really appreciate your feedback for any part of this talk to improve for the next talks, okay?
All right, thank you for your talk. I think I cannot really say anything about your English. I think it's perfectly fine, but your spasibo was just perfect. And I would assume it's much harder for me, like to say obrigado with a similar level of accent. So I would say that we need to wait a little bit between the translation and Zoom. So just around a minute until it's synchronized, and then we get to the questions. Ребят, да, если вы хотите задавать вопросы, я напоминаю, что вам надо перейти в Zoom, где мы это делаем, и вам надо тогда когда вы задаете вопрос, отключать трансляцию. Не забывайте поднимать руку. И если у вас есть проблемы с формулировкой вопроса, то, конечно, спрашивайте по-русски, мы поможем, если что, перевести. Вот. While we're waiting for a question, I have one of my own. I was recently improving like stabilization of our data pipelines in a company, and I ran into the fact that there's not that many tools available for PySpark end-to-end testing that are easily integratable to CI infrastructure. Like how you typically solve that? Do you have a local PySpark cluster inside, for example, Docker container, and then you run the pipeline? Or is there any tools that you can use to avoid that? Because I assume it's quite heavy on the CI system. У меня есть ощущение, что наш спикер отвалился, поэтому даже не знаю, да, мы можем попробовать поговорить между собой, может, у кого-то есть какой-нибудь интересный опыт, или он хочет поделиться, как он или она хочет поделиться тем, как они тестировали или там разрабатывали, набивали шишки на продукторизации дата-пайплайнов. Я, например, знаю, что Луиджи, про который упоминалось, он уже считается deprecated и неподдерживаемым, и все вот активно переезжают на Airflow. Даже те же ребята из Spotify давно уже пытаются переводить на него пайплайны. Мы вот активно используем Airflow в нашей компании и тоже столкнулись с тем, что пришлось все докеризировать, и там гигантские докер-образы для Spark Job, они вынуждены скачиваться и иногда очень сильно нагружать сеть. Так.
Я не Робсон, но привет.
Да, привет. Борода просто шикарная.
Специально отращивал, сидел в карантине. Так вот, собственно, Тут ответ очень простой и очень сложный одновременно. Это долго и мучительно, потому что нет готового рецепта, как вот сделать сразу все хорошо. Тут, к сожалению, придется страдать, тем более технология относительно новая. И... Ой, кстати, кажется, мы видим Робсона.
Так, ну мы пока можем продолжить поливать. Да. Похоже, Робсон нас не понял и ушел в дискуссионную зону, поэтому можем здесь продолжить пообсуждать. Мне интересно, да, закончить мысль про страдания. Я люблю страдать. Вот.
Oh, we've been just discussing that. Okay. I think you can repeat your question in English so we can join Robson to our discussion.
Yes.
All right. Yep. Okay, I guess that the discussion will continue in the discussion room.
Okay, everybody left us.
Okay, perfect.
Okay, let's check if anyone have questions in Discord. Just a moment. Okay, nope. No questions.
Okay, no worries.
Yeah, I think your talk was really understandable and everybody, oh, we should really implement it right now. Yeah, actually, I have a question of my own.
For sure.
We have recently implemented a streaming pipeline, and now I've got a pretty tough question. How can I sleep at night? Because it can break at any moment.
The question of the stream pipeline is I told so is about the code, because you have the cons that you need to at least know how your data scheme is coming, because if the data coming different, probably your pipeline will break all the time, or they will deliver you empty data. I suggest to you also to start to modeling your data from start, it's from the beginning, and define a scheme of validation for you on which message you are using, Kafka.
Oh, yes.
So you can use like a message, JSON messages or Avro messages that you can define. I recommend you to use Avro messages or Avro files for that you can define, well-define the schema for that. And you make sure that if your data that are coming is different from the schema, you can send it to different queues and just process the data that you can. This you avoid you to break your pipeline.
Oh, okay. We have a jury who joined us. Do you have a question?
Я зашел послушать. Может, кто-то еще что-то задаст, там расскажет другие вопросы.
Oh, we have a colleague who joined us to listen. Okay. So another terrible question, because a lot of people who are not in this room will probably asking this one. We have a bunch of scripts which do ETL jobs, like a lot of Python scripts, SQL scripts, a lot of homegrown pipelines which use some bash scripts and a lot of scripts running on cron, and people look at it like crazy, what's going on, and nobody does anything to it because it works. How to switch to something better like Airflow or
Okay, for this scenario that you have different kind of scripts, the best scenario is to migrate or to start to implement their Airflow. Why Airflow? Because Airflow can handle any kind of process for that. For example, you have Bash scripts, you have like Python scripts, you have SQL scripts, and then Airflow can handle which kind of this kind of process like, and then you can link between in a Pythonic way how the process depends of each other, like in a graph or in a DAG. It means that you need to execute these Python scripts. If they return exit 0 or success, they come to the next and they can run a SQL script on a database, and then you can get this result, and then you can implement or you can execute the next step. This is the advantage to use the Airflow and bring your legacy data pipeline into a more professional way. If you have time, it's another suggestion. If you have time and money to invest, I would suggest you to use the Luigi approach, because the Luigi approach has the same concepts. You can execute Bash scripts, you can execute SQL scripts over a Python driver, right? So DB API 2.0, and then you can execute, for example, Python scripts, MapReduce scripts, or Spark scripts in a Pythonic way as well. Everything integrated in the same code base, right? That's an awesome approach as well. But using these legacy requirements, I would suggest for the first try to implement the Airflow.
Okay, cool, thank you. And okay, and if we go into batching or micro batching, I see the results from voting. Oh, where is it? Where is it? Okay. Where is it? Someone stole the vote. Here it goes. Okay. When I asked people what do they use, for the data processing, either batching, micro batching, or streaming, I just for fun added the first response, and for some reason it leads the vote right now. So how do you know when to use batching or micro batching or switch to streaming?
So it depends the nature of the data product that you want to use. Let's start about the streaming process. Streaming process means that you need basically real-time data being served for some proposal. Again, let's use the example of the bank, a credit card company that needed to decide in few seconds, in few milliseconds, if they should approve or not your payment in the supermarket, for example. This is the kind, and based in this scenario, you have a machine learning model that is being trained all the time to make to let this algorithm to decide if you can approve or not this transaction. This is a typical scenario for a streaming process, because you are receiving a bunch of data, right? Not just the transaction. You are receiving a bunch of data like amount, you are receiving the localization, you are receiving the profile of the user. So you have a different variables that you need to process in a real time and deliver a yes or no, for example. This is one scenario that you need to use a streaming process and a powerful tool like Kafka, Spark, or another machine learning tool, for example, or a Dask for that. But if you have, like, for example, a user behavior analysis for A/B test, for example, it's a common scenario. You deployed a new button in your website. You change from blue to green. Okay, so, and you wanted to see if it's converting more products being selling for you. right? But you don't need to know it in a real time. This is a batch process because you collect all this behavior and then you get this part of subset and you compare with your historical data. This is a batch process, right? But if you decide if it's a mini batch or a small batch or a big batch, depends the nature of your products. What you need to answer is, it's not the amount of data, but if you need to parallelize your data, for example, right? Small data need to be parallelized because what matters here is the latency, right? For example, if you have like a big data set in your notebook, you have like 20 gigabytes of CSV file, right? But you have like a big, powerful notebook with supports to you open this file, and then you can process and do like a small batch process just in your machine. You don't need to parallelize it if you do it once, twice per week, for example, or whatever. Like even you just use a simple machine in your cloud provider. But if you need that, if this batch requires to be executed every day, if this data you grow up, if you need it to be fast, of course you need to parallelize it. It has become a batch process, a simple batch process that can be handled by Spark, for example, or for the Dask, depends if you need analytical time. But in a general way, it's so easy to implement a batch process in Spark and execute a Spark job in a cheap way that it doesn't make sense you to differentiate many batch process to a batch process. Just implement an easy way in a Spark way and deploy it like in a very small cluster that you have like the same result for you.
Oh, okay, thank you very much. If no one else have questions, I'd like to thank you for very nice talk and for really good insights you provided. Okay, I think it's bye-bye.
Thank you so much, everything. So thanks the invitation again. I love to talk and hope to see you soon soon.
Yeah, stay safe.
Bye-bye. Stay safe as well.
Bye-bye.
Thank you so much. Bye.
Yep. Thank you. Goodbye.
Please note that there is a link to Zoom after party. So if you're interested, you can click it. It is in the chat part, so you can join.
Okay, perfect.
Party part. Okay.
Thank you.
Thank you. Bye-bye.